I needed a very specific dungeon generating algorithm that would create fairly complicated mazes without using stack and without using too much memory, obviously fairly fast. The one I found that wouldn't create, for example, a long tunnel, open side like a Sidewinder or binary maze, and that wouldn't take stack or excessive amount of memory in form of arrays for the backtracking was Hunt&Kill algorithm generator, but it has a problem, not only that it takes a lot of time, but it takes significantly more time the shorter the length of the path generated is. So basically the way it works, as you can see here, every time it cannot generate a path, it reached the dead end, or the length of the maximum length of a path that was set up, it scans the array top to the bottom, which especially for the short paths takes a lot of time. So this single maze takes about 5 minutes. Obviously that's not the actual time it would take, because there's actually several additional loops included specifically for the visualization to be visible, so that you can actually see what it's doing. It's much slower than it would be normally, but still it is the same settings as the other two versions will have, and you can see how much longer it is. So I was thinking, it scans the array from top to bottom every single time it gets to the dead end. This is very slow and unnecessary. So I was thinking about a single modification. So rather than actually scanning the array from top to bottom every single time, let's start at the point that the last section of the dungeon or maze or whatever path was generated, and move on. Modification which I've called serial Hunt&Kill, because it frankly kills or carves a series of cells in a row close together and much faster. This is painfully slow to watch. So this is serial hunt and kill, and you can see that the scanning is mostly trailing at the end of the last generation. This basically allows it to find a series of loose ends without the need to scan the uncarved areas over and over again. It's much faster. It's about 5 times as fast from what I've seen. Right, so it is much faster, but it does occasionally skip one or two areas with uncarved sections. And I was thinking, what if, rather than just allowing it to search downwards from the last place it finished carving, what if it would actually go up by one row and start it from there? That way it will scan one more row of cells every time. However, it would most likely find all the loose ends, or at least most of the loose ends, in just a single full scan. So the next algorithm will have that modification or that upgrade implemented. This one I called Poacher, because it not only hunts the cells that are close together and basically starts where the generation finished, but it also tracks down all the loose cells in the neighborhood. So basically poaching all the targets it can find in the area. So usually it finishes in a single pass, sometimes two, adding the third one. This improves the speed slightly less. First modification improved it 5 folds. Second modification added another 20% perhaps to the overall speed, but it also increased the consistency a lot. So almost regardless of the size, so at the moment this is 45 by 45 grid, it takes about the same amount of time to generate labyrinths, pretty much regardless of the complexity. So whether the paths are set to 1 step or 2 steps or 200, it will take approximately the same amount of time, which is extremely good for the purpose I needed, as it gives predictable results. And we can see how it follows and kills almost every single last 3 space in a single pass, finishing the job on the second usually. There will be some examples with different path lengths at the end. I just wanted the first 3 algorithms to be on the exactly same settings, so the same cycles on the DOS box, same delays, same path length. So there it is, Poacher, Hunt and Kill.